this video, we're going to look at the gradient of a straight line. We'll start by defining what we mean by the word gradient, and then we'll look at a few examples. So, the gradient of a straight line is the number given by the formula m equals y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are any 2 points on the line. Let's make a few observations about this definition, and then we'll try a few examples. So note that the gradient is often denoted by a letter m. You can see in my definition I've used the letter m, and this is very common. In most textbooks you'll find they use the letter m when discussing the gradient. It will always be the same, it doesn't matter what 2 points you choose, so if you look at the definition it just says you can take any 2 points as long as they lie on the line, plug them into this equation and you get the gradient for the line. So regardless of what 2 points you choose, you'll always get the same number coming out, so the gradient for a given line is a fixed, constant number. And you can calculate it using any 2 points on the line. And finally, it lets you know the steepness and the direction of the line. So that's really what the gradient is. It's a measure of the steepness of the line, and also depending on what sign, whether it's a plus or a minus sign, it tells you what direction the line is moving in, if you like. But we'll focus on this in the next video. So for this video, we're just going to look at a few examples of calculating gradients for a few given equations, and in the next video we'll look at how to interpret the gradient. So let's try this example. Calculate the gradients of the following lines. So we have y equals 2x, y equals a half x plus 1, and y equals minus x minus 2. Hopefully you recognize all three of these as straight line equations, but let's try calculating their gradients. So for question 1, I'm going to start by sketching the line, and to do this I'm going to calculate 2 points. So I'll finish off this table here. So what is y when x is 0? Well, I plug that into my equation and I get that y equals 2 times 0, which is 0. So the point 0, 0, which is this red dot here on my axis, lies on this line. Then I plug in x equals 1 and I get y equals 2 times 1, which is 2. So the point 1, 2 also lies on the line, so I simply draw a line through them. This blue line is the line for y equals 2x. So to calculate the gradient now, I need 2 points that lie on the line. Well, I've just calculated 2 points, so I'll just use them. So I have this point here, the point 0, 0, so this is my x1, and this is my y1, and I have this point here, 1, 2, so this is my x2, and this is my y2. Now hopefully you remember from a previous video in this series that y2 minus y1 is essentially this length here, and x2 minus x1 is this length here. So we discussed this in a previous video. If I have 2 points lying on a line and I make this right angled triangle here, then the difference between their y coordinates is the vertical side, the length of the vertical side, and the difference between the x coordinates is the length of the horizontal side. Now the gradient by definition is just the vertical length divided by the horizontal length. So what is that in this case? Well, you can see from the triangle, or you can look at y2 and y1 and x2 and x1, and you can deduce that it's 2 divided by 1. So we have 2 minus 0, which is 2, and 1 minus 0, which is 1. So 2 divided by 1, which is of course just 2. So m equals 2 for this blue line. Let's try example 2 now. We'll once again plot 2 points that lie on the line. So if I plug in x equals 0, I get a half times 0, which is 0, plus 1. So I get 1. So 0, 1 is this red dot here on my axis. Then I plug in x equals 1, and I get 1 times a half, which is a half, plus 1, which is 1.5 or 3 over 2. So 1, 3 over 2 is here on the axis, and hence the line looks like this. Once again, I can calculate the gradient by doing 3 over 2 minus 1, which is a half, divided by 1 minus 0, which is 1. So I get m equals a half divided by 1, which is 1/2, of course. So m equals a half for this orange line. Finally, I will calculate the gradient for the equation in question 3, y equals minus x minus 2. Once again, I will plot 2 points. So when x is 0, I get 0 minus 2, which is minus 2. That's this point here. And when x is 1, I get minus 1, minus 2, which is minus 3. So 1 minus 3 is this point here. So here is the line for the equation y equals minus x minus 2. It's this green line here. Once again, I'll calculate the gradient. So y2 minus y1 in this case is minus 3 minus minus 2. So let's put this down here. M equals minus 3 minus minus 2 divided by, well, once again, x2 minus x1 is just 1 minus 0. So minus 3 minus minus 2 is minus 3 plus 2, which is minus 1. And 1 minus 0 is just 1. So I get minus 1 over 1, which is minus 1. So the gradient of this green line is minus 1. So that's how to calculate the gradient for a line. In the next video, we're going to look at how to interpret the gradient. We're going to look at what the gradient actually tells us about the line.
And she saw that swirl of